Question we have shown up making the following claim. N is an even positive integer greater than 2. And that implies that 2 to the power of n minus 1 is not prime. Prove that Schoner's claim is true. Okay, so first things first, we can't use that GCSE definition for an even number as 2n because we've already got the letter n being used. However, we can define an even number using just a different letter. So we'd start off with the statement an even number is represented by n, because that's what we've been given in the question. We're going to let that equal 2k, because now we know that that is even. And define it further, where k is greater than 1, and is an integer. Okay. So we can now rewrite 2n minus 1 as the following. As 2 to the power of 2k minus 1. Okay, because we replaced n with 2k. We can make that go a little bit further and just break this up into 2 to the power of k, and then that's all squared. We've just split 2k into k and to the power of 2, and that's take away 1. The reason we've written that in this form is because now we should be able to recognise that this here is a difference of 2 squares. The difference of 2 squares allows us to factorise. Okay, because now we've got to this stage here, if we can prove that both of these numbers here are greater than 1, they would therefore be positive integers multiplied together. And if they multiply together to give 2 to the power of n minus 1, that would therefore mean that this could not be prime because it is the product of 2 separate integers. Okay, so we're going to take this statement a little bit further and just examine 2 to the k plus 1. Well, we know that 2 to the k plus 1 is greater than 1. Okay, because 2 to the power of anything, when k is greater than 1, add 1 to it, it is going to be greater than 1. Okay, so we know that k is greater than 1 because that's how we defined an even number. So if 2 to the k plus 1 is greater than 1, this would also mean that 2 to the k minus 1 would also have to be greater than 1, okay, due to the definition of the even number that we had at the start. So therefore, what this means is that because both of this number and this number are both greater than 1, the statement that we've just made is a product of 2 integers. And these 2 integers are greater than 1. Okay. So since 2 to the k plus 1, 2 to the k minus 1 multiplied together equal 2 to the n minus 1, which is the original part of the question. 2 to the n minus 1 is not prime. And therefore, this claim is true.